Citicorp Building, Engineering Wonder or Manhattan Time Bomb. In 1978, as New York was still enjoying a prosperous life after the economic crisis of the 1970s, a dark secret was gradually revealed inside one of the city's most iconic skyscrapers. The Citicorp Center, now Citigroup Center, a 59-story architectural wonder with a unique, standing on piles, design, turned out to be at risk of becoming the cause of one of the biggest construction disasters in American history. The origin of the bold idea. The story begins with the challenging request of St. Peter's Church, which refused to leave its historic location to make way for Citicorp to build its new headquarters. The deal was made. The church would be replaced with a modern new building, and the Citicorp Tower would float above it without invading the church's space. Architect Hugh Stubbins and structural engineer Bill Lemessurier decided to build the tower on 4 piles, not at the usual corners but in the middle of each side. This idea opened up a bold engineering solution, using V-shaped diagonal braces to transfer the weight down to the piles and keep the building upright. Horrifying discovery. However, just a year after the building was completed, Lemessurier suddenly realized a serious flaw. During a re-evaluation of the design, he discovered that the welds used to connect the cross braces had been replaced with bolts, a decision made by the contractor to reduce costs. This seemingly small mistake turned out to be a potential disaster. Analysis showed that if a hurricane with winds of 70 mph hit, the building would not be able to withstand the pressure and would risk total collapse, killing thousands of people and destroying Midtown Manhattan. A life and death decision. Lemessurier faced a stark choice: keep quiet and hope for the best, or go public and try to fix it, even if it meant ruining his career. Ultimately, with his work ethic and courage, he chose the latter. Under the guise of routine maintenance, Citicorp undertook a covert nighttime repair to reinforce the welds by adding steel plates. The work was completed just weeks before a major hurricane was expected to hit New York. Unanswered questions. The incident raises many unanswered questions. How could such a major flaw have been allowed to occur in the first place? Why were design changes not properly controlled? And could Citicorp have covered up the problem if a disaster had actually occurred? The controversial story of wind loads and V-bracing. In the architectural industry, dealing with wind loads is a major challenge, especially when designing skyscrapers. One prominent and controversial story involves the design of the Citicorp building in New York, which illustrates how engineering and creativity have been used to address this issue. Wind loads and building frame deformation. When wind acts on corner columns, the entire frame of the building tends to deform. To minimize this deformation, a common solution is to reinforce the joints. However, design engineer William Lemessurier realized that there was a better solution. He reasoned that beams and columns are much better at resisting compression and tension than bending loads. Therefore, adding diagonal bracing to the structure can help to resist horizontal loads more effectively. The beams in the system act like springs. When compressed, they push against the joints. When they are stretched, they pull the joints closer together. In a V-bracing system, wind loads cause simultaneous compression and extension on the diagonals, with the left column pulling down in tension and the right column pushing up in compression. As a result, these forces are transmitted through the floors and V-shapes, creating a load distribution chain from upper to lower floors. V-bracing and a unique design problem. The V-bracing system in the Citicorp building was designed to effectively transfer wind loads to the lower part of the building. However, Citicorp could not install conventional corner columns due to architectural requirements and gravity loads. Therefore, the V shape not only carries wind loads, but also prevents the triangular blocks from rotating in high winds. A major challenge was the size of the braces. Each was nearly 130 feet long, a size that could not be easily transported across Manhattan. The solution was to fabricate them in smaller sections and weld them on site. This not only saved money, but also reduced the overall weight of the building, making Citicorp one of the lightest structures in New York, weighing in at just 22 pounds per square foot. Problems and solutions. However, making the building lighter also created a problem. It swayed easily in strong winds. While not a serious structural problem, the swaying could be uncomfortable for residents and visitors. A common solution is to add more structural steel to increase stiffness, but Le Mesurier came up with a more elegant solution, using a counterweight system to dampen the vibrations. Tuned mass damper, innovation and unexpected payoff. In the engineering world, tuned mass dampers, TMDs, have long been a go-to solution for damping the vibrations of suspension bridges, power lines, and ships. However, when William Le Mesurier decided to use the technology in the construction of Manhattan's Citicorp Center, one of the tallest and most advanced buildings at the time, he could not have imagined that the decision would become one of the greatest technical and ethical controversies in history. Innovation and early impact. The Citicorp Center's TMD was designed to reduce the amount of sway a building experiences in high winds, especially during high-level storms. It was the first time such a system had been used in high-rise construction, weighing 400 tons inside an 8-foot-thick concrete square. TMD helped Citicorp Center reduce its vibration amplitude by up to 50% compared to the original design. This technology not only increased the building's safety, but also saved about $4 million by reducing the need for structural steel. The combination of V-shaped braces to distribute forces and TMD made Citicorp Center an engineering icon of its time. The press hailed the building as an architectural acrobatics, and the American Institute of Architects awarded it an honorary award, calling it a masterpiece of a skyline. Everything seemed to be going according to plan. Potential crisis. But then a shocking discovery shattered the building's reputation. In 1978, a college student questioned the building's V-shaped trusses in a group assignment for Le Mesurier. After reviewing the design, Le Mesurier discovered that the trusses had not been constructed to the original specifications. Instead of using load-bearing welds, the trusses had been bolted together, significantly weakening the structure. In a particularly high wind situation, the building was at risk of collapse. At the time, experts modeled the situation and estimated that 1 in 16 storms a year could cause the Citicorp Center to topple. Ethics and response. Recognizing the danger, Le Mesurier decided to do something rare in the industry. He reported the engineering defect to the building owner and the authorities. In as much silence as possible, 200 workers worked through the night for 2 months to reinforce the beams with welding. Although there was no immediate disaster, the Citicorp Center saga has sparked a long-standing debate about ethical responsibility in engineering. Should Le Mesurier be hailed as a hero for admitting his mistake, or should he be blamed for allowing it to happen in the first place? Either way, the Citicorp Center remains a valuable lesson in engineering, ethics, and responsibility. Anonymous student. The story of the Citicorp Center, one of the most prominent and controversial architectural projects of the 20th century, is a vivid example of courage, but also a reminder of the risks involved in combining engineering and creativity. In May 1978, Bill Le Mesurier, a renowned structural engineer, was discussing with a client the use of welded V-shaped ties on a project. The architect and the steel fabricator questioned the effectiveness of welding the ties. Le Mesurier, with the confidence of an expert, replied that everything was fine. But when he called his engineering team in New York to confirm, he discovered something surprising. The ties he had calculated to be welded were bolted instead of welded. The decision to change was motivated by a cost-saving idea. The contractor proposed replacing the welds with bolts, which would save about $250,000. Le Mesurier initially had no doubts about the decision. Bolts could work just as well in some situations, and in fact could be less expensive than welds. But as he thought about the change in design for a skyscraper with such important bracing, he couldn't help but feel uneasy. Just a month later, Le Mesurier received a call from an engineering student. The student wanted to discuss the Citicorp Center, and he was highly critical of the building's central columns, calling them a serious mistake. The student's teacher even said, "Nobody should put columns in the middle. They should put them at the corners." "That's ridiculous." Le Mesurier was offended by the criticism and responded that the students didn't fully understand the problem they were solving. But something interesting happened. While discussing with the students, Le Mesurier began to question his calculations. The image of the Citicorp building as a triangular skyscraper gradually became clearer in his mind. Why were the columns in the middle instead of at the corners? The change in the position of the columns was part of a strategy to make the building more resistant to wind loads. But Le Mesurier had not given enough thought to another important factor: wind loads from the corners of the building. A few weeks after this call, Le Mesurier decided to take some time to review all his calculations. He discovered that wind loads from the usual directions were not the biggest determining factor. It was the wind blowing into the corners of the building, creating a powerful force that had not been fully accounted for, that posed the greatest threat to the structure. In retrospect, Le Mesurier realized that the failure to consider all the possibilities of wind from different directions was a serious mistake. It could have led to disaster if not corrected in time. This left Le Mesurier with one of the most difficult decisions of his career. Could he publicly admit the mistake and correct it without causing a crisis? Or should he accept the consequences of the design flaw? Finally, Le Mesurier made a bold decision. He decided to stand up and correct the mistake. He contacted the authorities and reported the problem, demanding an immediate solution. He and his team then quickly developed a plan to repair the building, adding additional security measures. With these changes, the Citicorp Center still stands, becoming a symbol of innovation in the architectural industry. However, the story of error and correction has created a great controversy. Can Le Mesurier be forgiven for his poor calculations? Or will his courage in correcting his mistake be recognized as an act of courage? This story is not just about engineering, but also about ethics, about the decisions that engineers and architects must make in times of crisis. The Citicorp Center has become a lesson in the importance of not only adhering to engineering principles, but also putting safety and responsibility first. The price of carelessness. In the world of construction, sometimes a small change can have a big impact, not only on the structure of the building, but also on the careers of those involved in that project. In the 1970s, Bill Le Mesurier, a talented civil engineer, created a masterpiece, the Citicorp Tower in New York. This building is notable for its unique design. The main columns are offset 45 degrees from the sides of the building, creating an interesting but structurally challenging V shape. Le Mesurier faced a serious engineering problem when designing this building: wind. Wind is an extremely important factor when building tall buildings. Strong winds, especially at high altitudes, can create extremely large tensile and compressive forces, affecting the stability of the entire structure. During his calculations, Le Mesurier had divided the wind forces into perpendicular components in order to determine exactly how much load the building structures would have to bear. He calculated that the perpendicular wind forces would be divided equally between the columns and braces, and this checked out thoroughly. But then things started to change. Something strange happened during the recalculations. Le Mesurier noticed that the wind forces were not quite as perpendicular as he had thought. The crosswinds' winds blowing obliquely changed everything. This meant that the braces, especially on the 30th floor, not only had to withstand greater wind forces than expected, but they also required double or even triple the number of bolts than had been originally calculated. When the bracings were subjected to a wind load of 635 tons instead of 454 tons, Le Mesurier realized that the bolts his company had installed might not be strong enough. The original calculations had called for each bolt to support about 28 tons, but with the new load, each bolt would have to support at least 75 tons, while the number of bolts used was too small. The story didn't end there. With growing concerns, Le Mesurier decided to fly to Canada to double-check all the calculations with experts at the Boundary Layer Wind Tunnel. There, he discovered something much worse than he had imagined. His calculations had assumed that the building was stationary, with no movement due to wind. However, wind tunnel tests showed that the building would move, and as the building moved, the wind forces on the struts could increase by up to 60% of what was originally predicted. Le Mesurier was stunned. The truth was too harsh. The building's weakest joints were on the 30th floor, where the bolts could not withstand the force of the wind. If these joints failed, the entire building could collapse, causing unimaginable disaster. Le Mesurier's heart was in turmoil. He couldn't believe what he had discovered. The miscalculations, the weak joints, and the change in the way wind loads were calculated posed a serious threat to the tower he had worked so hard to build. What would happen if things weren't fixed in time? Could a miracle save the project? Le Mesurier knew he had to act quickly, but he knew that this truth could change everything, including his career. With tensions running high, Le Mesurier decided to immediately report to the contractors and company leaders, recommending upgrading the joints, adding more bolts, and adjusting the wind load calculations to ensure the building's safety. But was this intervention timely? And did anyone listen and act in time before disaster struck? This story of a brilliant engineer and a challenging design will go down in history as an important lesson in meticulousness and care in construction engineering. And the Citicorp Tower, while standing today, remains a living testament to the sophistication, but also a costly lesson in how errors in calculation can lead to disaster. On the edge, the courage and choice of Le Mesurier. In a city that never sleeps, one man faces a decision that could change his life and the lives of thousands. Le Mesurier is a brilliant structural engineer who has poured his heart and soul into designing Citicorp, the skyscraper that dominates New York City. But just a year before the building was to be completed, Le Mesurier discovered a critical flaw in his design, one that could lead to the collapse of the entire structure. To make matters worse, his calculations showed that although the building could withstand strong winds, if a powerful storm like Hurricane Bell passed through the city and knocked out the power, the building could easily topple. Winds gusting up to 70 mph for just 5 minutes could be enough to bring Citicorp down. Le Mesurier knew that the building, although perfectly designed, was not strong enough to withstand a major storm without a modified mass damper. Calculating the likelihood of collapse itself was a major concern. With a storm strong enough to strike every 67 years and a 1 in 16 chance of such an event occurring in any given year. It was possible that in that year, the building would be hit by a storm, strong enough to cause it to collapse. A sense of tension and fear weighed heavily on Le Messurier's mind. Was there any other choice, he wondered, than to face this terrifying truth? If the mistake were discovered and made public, he could face lawsuits, bankruptcy, and worst of all, the collapse of his career. But if he remained silent and did nothing, he would put thousands of lives at risk. In July 1978, Hurricane Belle swept through New York, bringing with it high winds and a roaring sound. Le Messurier, watching the storm, realized that the situation was becoming dire. It might be the end of the building he had worked so hard on, and it might be the price he had to pay for his careless design. It was a painful moment when he realized that if things did not change, within a year, the building could be the reality of an unwelcome disaster. In a later interview, Le Messurier admitted that, in the midst of the crisis, he had some extreme thoughts. I said to myself, I could drive down the main turnpike at 100 miles an hour and deliberately hit the bridge abutment. That would be the end, and everything would be gone. I thought about it, but he knew that if he didn't act now, the fate of the building and all those inside would no longer be in his hands. In the end, Le Messurier didn't choose to stay silent. He decided to confront the problem, even though it was a risky decision. After consulting with several lawyers, he decided to go public with the error and seek immediate redress. This decision, although arduous, was the only step he could take to ensure that no one would pay for his mistake with their lives. Le Messurier's story is not only a lesson in courage and responsibility, but also a reminder of the importance of recognizing and facing the truth, even if it hurts, because only then can unforeseen disasters be avoided. The story of the Citicorp building renovation, also known as Project Serene, is a classic example of how engineers and construction professionals tackled an extremely difficult challenge under high pressure and with little information. Here's how to tell the story. Project Serene, the secret behind a dangerous remodel. The Citicorp building, one of New York's most prominent towers, faced a potential safety hazard that threatened the safety of thousands of people who worked and lived in the area. Several elements of the building's design, particularly the structural steel beams and the mass damping TMD system, were unable to withstand changing weather conditions and high winds, especially during hurricane season. When Le Messurier, the leading engineer, discovered the problem, he and architect Stubbins worked day and night to find a way to fix it without causing public panic or unnecessary fear. The building had been designed with a mass damping system to stabilize the sway of the tower during severe storms. But now the system needed to be adapted to become a means of maintaining the building's stability. With the plan carried out in secret, Le Messurier called the project Project Pandora, but later renamed it Project Serene. To minimize concerns, repairs began overnight as welders worked silently, replacing and reinforcing the building's joints, all under the watchful eye of the engineering team. More than 200 joints needed to be repaired, starting at the top floors, while the office staff were unaware of the changes. However, the problem was not limited to repairing the joints. Citicorp needed to prepare for the worst, where a failure could lead to the collapse of the building. In order to ensure safety, the company worked with the Red Cross to develop an evacuation plan for everyone in and around the building. But instead of making the information public, Citicorp chose to keep the truth under wraps to avoid causing panic in the community. While the repairs were being carried out, Le Messurier received special assistance from AT&T, which installed emergency phone lines to monitor the building's stress indicators. The project, while kept secret, could not escape the curiosity of the media. Finally, on August 8, Citicorp issued a statement about the repairs. Although the story was incomplete, it caused some in the press to begin questioning what was really happening inside the building. In a tense situation, Le Mesurier faced a major challenge. Newspapers, including the New York Times, tried to contact him. However, when he called them back, a strange coincidence occurred. All the New York newspapers were on strike, lasting until October. This allowed him to keep the news of the building's condition under wraps for a while longer, allowing the repair work to continue uninterrupted. By the end of August, as time passed and the repairs were completed, people were still worried about the safety of the building and those around it. This uncertainty was finally revealed when the Serene project reached its completion. But it was just one of the century's most important events of courage and ingenuity in construction. This story is not only a lesson in engineering, but also a testament to the patience and willingness to face crises in the construction industry, along with difficult decisions that sometimes cannot be shared with the public immediately. Hurricane Ella and the secret that almost buried New York. That summer, a storm named Ella quietly formed off the Caribbean. But it was more than just another storm. To those involved, Ella was an urgent warning of a potential disaster that few outside of them knew about. In New York, a proud skyscraper, the Citicorp Center, was undergoing quiet repairs. Only half of the reinforcements were complete. The man behind the structure's design, legendary engineer William Le Mesurier, was grappling with a grim truth. The building could collapse from a single misaligned storm, something that models at the time had largely ignored. And Ella was a storm that would only come along once every 200 years. Le Mesurier wasn't betting thousands of lives on being able to withstand it. He knew that if Ella hit Manhattan head-on, and especially at an angle, Citicorp would fall like a giant domino, causing a catastrophic chain reaction in downtown. On September 1, Ella accelerated and headed straight for New York. City officials began quietly planning an evacuation of a 10-block radius around Citicorp, an unprecedented peacetime plan. Police were prepared to knock on doors at night. For 24 terrifying hours, Le Mesurier and his team of engineers and city officials barely slept. No one but them knew that a portion of downtown would collapse like a playing card in the next few hours. But then, in the middle of the night, Ella changed course. The storm turned out to sea at the last minute, swept north, and hit Canada with winds of 140 mph. New York was saved, but saved silently. No one but a small group knew that one of the worst building disasters in American history had nearly happened. The building was quietly repaired in October, without a press conference, without a statement. The morning after Ella had avoided New York, Le Mesurier looked up at the tower and said, "It was the most beautiful day the world has ever seen." Not because it was a warm, sunny day, but because they had just escaped a disaster no one had ever predicted. TMDs. Take over the world. The secret that almost sank New York changed human architecture. Just 6 weeks after engineer William Le Mesurier revealed the horrifying truth to Citicorp management that the 59-story building could collapse in crosswinds, they took action. Hastily, quietly, the most secretive major surgery in American construction history began. The cost of the repairs? $4.5 million. A huge sum. But Le Mesurier argues that they had approved another design that cost $5.6 million more. It wasn't about money. It was about reputation and lives. And then it was buried for nearly 20 years. No press conference. No public inquiry. No written lessons. Only an internal group knew that a Hiroshima-scale disaster had quietly passed by on a windy night, without anyone in New York knowing. It wasn't until 1995 that the New Yorker broke the story. Project Serene, the internal code name for the secret repair operation, was finally exposed. But instead of being criticized, Le Mesurier was hailed as a hero for having the courage to admit his mistake and fix it before anyone died. The story doesn't end there. What few expected was that the crisis would give birth to a technology that would change the world of modern construction forever: tuned mass dampers, or TMDs. The Citicorp building became the world's first skyscraper to be mechanically supported to hold its structure in place. An idea ahead of its time. And like all great things, it started with a near-fatal mistake. From there, TMDs took over the world. In Japan, where TMDs have become so ubiquitous as to be a survival standard in the face of typhoons and earthquakes, Le Mesurier is regarded as a tin god, a title he still marvels at when recalling. I said, "Really?" Today, 6 of the world's 20 tallest buildings have TMDs, giant machines weighing hundreds of tons that swing like pendulums inside concrete cores. Taipei 101, for example, with its 660-ton golden pendulum, can withstand winds of 200 km/s, measuring over 6.8 on the Richter scale. From a secret that almost caused disaster to a technology copied hundreds of times around the world. But one wonders, if Typhoon Ella hadn't changed course at the last minute, would we remember the Citicorp Center today as an iconic structure, or as the wreckage of the biggest cover-up in American history? Citicorp, conspiracy, cover-up, and the mystery of the student who saved the city. In 1978, an unknown college student nearly saved thousands of lives in New York. But to this day, we're still not sure who it was. Diane Hartley, a structural engineering student at Princeton, is credited with being the first to notice a serious flaw in the design of the recently completed Citicorp Tower. She was writing her senior thesis. She couldn't find any analysis of crosswinds, a dangerous but overlooked factor in the original wind model. When she asked, she was assured, "Crosswinds are not a problem in this design." Trusting the renowned engineers, she kept quiet, graduated, and left the story. That was the end of it. But nearly 2 decades later, in 1995, an article in the New Yorker rocked the architectural world. The Citicorp building almost collapsed. In silence. In secret. And the repairs were done in secret. In the shadows of the city. On nights when residents had no idea they were living on the edge of death. Watching the BBC documentary about the incident, Diane Hartley almost dropped her newborn baby. There was talk of an engineering student in New Jersey who contacted Chief Engineer Bill Le Mesurier. Diane never called him, but she had done her thesis on Citicorp in 1978. Had she inadvertently set off a chain of events she herself was unaware of? And then, in 2011, a new name emerged. Lee DeCarolis, a student at the New Jersey Institute of Technology. He claimed it was he who called Le Mesurier. No claim to fame. No claim to fame. Simply said, "I thought it was interesting. I called." Le Mesurier died in 2007. He is no longer around to confirm. The question remains, who really saved New York? And why was such a story buried in decades of silence? Le Mesurier Associates declined to comment. It did not mention any renovations in its Citicorp project documents. The building, now called 601 Lexington and owned by Boston Properties, also refused to allow filming inside. Meanwhile, engineering organizations continue to praise Le Mesurier as a moral model, someone who took the risk to fix a mistake. But no one really talks about the others involved. No one wants to talk about the possibility that a senior student or a junior engineer was the first to notice the glaring error. In 2021, a new study from the National Institute of Standards and Technology, NIST, stirred the pot again. While it concluded that perpendicular winds were more stressful, it did not analyze Citicorp specifically, and the question of crosswind safety remains unanswered. Meanwhile, those who worked on the Citicorp project dodged the question. One said there were still raw emotions about the incident, as if we were not allowed to know the whole truth. Is this a moral lesson or a cover-up that was too well concealed? Has engineering really learned anything from Citicorp? Or have we just learned to reinterpret history in the least painful way?